In this video, we're going to go over a specific type of transformation called a reflection. And a reflection is basically kind of probably what you're imagining right now. It's just making a mirror image of a point or shape. So when you reflect something, you're kind of seeing the same exact image, just in a reflected way, meaning basically it's the same image kind of flipped and it's still congruent to the original image, right? When you look at yourself in the mirror, you see the same face, but if you look at like one of your shirts in the mirror, it'll be all the same letters, they're just kind of reversed in their orientation, right? So that's what we're gonna end up with here when we do coordinate reflections. All right, so for example, if we were to take, let's say, a rectangle, or let's say maybe a little weird pentagon like this, if we were to take a pentagon and reflect it across the x-axis, let's say, we would then be using our x-axis as our mirror image line. If we were to reflect this pentagon over the x-axis, we would end up with something that looks pretty much like this. Okay, so we're taking the same pentagon shape and we just kind of reversed it. If we were to look at this shape, the new image, it's going to be congruent to the original shape, right? So we're ending up with the same shape here, it's just oriented a little differently, and that's what we're going to end up with when we do these reflections. All right, so that was just a brief example. We'll go into these in a little more detail here. So you can use these rules to figure out if you have coordinates of a shape or a point, what is the new coordinate, what are the new coordinates going to be for the new image point. All right, so if we look at reflecting across the x-axis, the rule is you take a point x, y, and you negate the y coordinate to make this point x negative y. So that means if we had a point, let's say 2, 3, and we reflect it across the x-axis, it's then going to be 2, negative 3. Or if we take a point negative 4, 1, and we reflect across the x-axis, then that would be negative 4, negative 1. All right, so the only thing that's changing here in the case of reflecting over the x-axis is that we're negating the y-coordinate. So if it's positive, we're going to make it negative. If it's negative, we're going to make it positive, because if we take the negative of a negative number, that gives us a positive. So if we were to look at a coordinate like negative 2, negative 5, let's say, then we would then make this negative 2, 5. All right, so we took negative 5 and made it negative. That makes it positive 5. All right, so be careful when you're negating. If it is already positive, you're going to make it negative. If it's already negative, you're going to make it positive. All right, so we can use this rule to do an actual reflection. Let's say that we have a point 4, 2. So we have this point here, 4, 2. If we want to reflect it across the x-axis, meaning we're using the x-axis as our reflection line here, we would take the point 4, 2. We could apply our rule. That would make the point 4, negative 2. And then we could plot this new point 4, negative 2. We go to 4, negative 2. It would be down here. We can see that this point is just a reflection of the original point, right? We could measure the distance from the original point to the reflection line. That would be 2 units. And we can measure the distance from the new point to the reflection line, and that would also be 2 units, right? So we end up with the same spatial orientation relative to the original axis of reflection and the original point, right? So we can see this a little more clearly if we try and do reflections with shapes. So here we could take an example. Let's maybe draw ourselves a triangle over here. We could make a little triangle like this, and we could try and reflect it over the x-axis. So first we want to figure out what are the coordinates of our point here, or of the points of the triangle. So we have coordinates here. The bottom corner here we would have negative 3, 2. At the top corner we would have negative 3, 4. And then in the side point here we would have negative 1, 3. So we could take all of these points and apply this rule for reflecting over the x-axis and just negate the y-coordinate on all of them. So if we do that, we would end up with negative 3, 4 becoming negative 3, negative 4. We would have negative 3, 2 becoming negative 3, negative 2. And then negative 1, 3 would become negative 1, negative 3. So we could then plot these new points that we came up with. We have -1, -3. We have -3, -2. We have -3, -4. And we could draw our new shape by connecting our points here. And we can see this shape that we have, it's the same triangle that we started with. It's just reflected in the x-axis. All right, so the shapes, the image shapes that you come up with after applying your reflection are going to be congruent to the original shapes because we haven't changed anything about the orientation of the points relative to each other. All we've changed is how our points are going to look. Maybe the direction our shape is going to point. That was kind of hard to see in this example because I drew what essentially was an equilateral triangle, or an isosceles triangle. I guess this would not be equilateral quite, but we're going to end up with the same shape that we started with. It's going to be oriented a little differently. All right, so we could try this again with the y-axis, and the same concepts apply. So this time we're going to take the point xy, and now we're going to negate the x-coordinate and have it be -x, y. So the difference here, instead of reflecting in the x-axis, we're going to reflect in the y-axis here. So if we go to try an example with this, we could make ourselves a triangle. Let's say we come down here and do a triangle like this. Connect our dots, make ourselves a triangle. And if we want to reflect this in the y-axis, we're going to apply the same steps as the x-axis reflections, except now we're using the rule for the y-axis and negating the x-coordinate instead of the y-coordinate. So we could take the coordinates for all of our points. Here we have -4, -2. Here we have, I'll draw this up here, -2, -2. And then down here we have -2, -5. So if we apply this rule for reflecting across the y-axis, maybe use green here, we would end up with 4, -2, 2, -5, and 2, -2. So we have our 3 new points. We could then plot these 3 new points. So we have 2, -2, 4, -2, and 2, -5. Could connect our dots to make a triangle. And we can see here, the triangle that we have, again, it's congruent to the original triangle. We can measure the side lengths, we can measure the angles, and we would see that basically it's the same triangle. It's kind of flipped here, right? We had the triangle with kind of this pointy side over here facing to the left, and now the pointy side over here is facing to the right. But it's the same triangle, just oriented a little differently, right? We still have the same points, we still have the same side lengths. Everything is the same about this triangle, except its orientation is slightly different. All right, so with the y-axis reflections, you can see they're really the same as the x-axis reflections, except instead of negating the y-coordinate, we're negating the x-coordinate, and we're essentially flipping our shape across the vertical axis instead of across the horizontal axis. But you can see that the steps are very similar. All right. The last type of reflection that we're going to look at here is a reflection through the origin. And this is going to be a slightly different process because instead of negating one coordinate or the other, we're going to negate both coordinates. So we're going to go from xy to -x, -y. So again, if we took, let's say, -3, 4 as our point, and we applied a reflection over the origin to that point, we would then have a point 3, -4. Right, so if the x-coordinate is positive, you make it negative. If it's negative, you make it positive. Same thing for the y-coordinate. All right, so we negated both of these by changing their sign. All right, so what we could do is try out another example here with a triangle. Let's maybe move down here to quadrant 4. We can make ourselves a new triangle. Let's say maybe it looks like this. All right, and if we go to try and reflect this triangle again, we're going to follow the same steps, except now applying our rule for origin-based reflections. So we would want to get the coordinates for all the points here. We have 1, -5. This would be 4, -2. And this would be 2, -1. So we're going to apply the rule for reflecting across the origin to all of these points. So then we would have -2, 1. Again, the 2 was positive, so we make it negative. the 1 was negative, so we make it positive. We could apply the same rule here, -4, 2, and we could apply the same rule here, -1, 5. So we're negating both of the coordinates, or both the x and the y coordinate in this case, for all those points. So when we go to draw our reflected shape, we can just take the points that we plotted here, -2, 1, -4, 2, and -1, 5. We could connect our points to make our triangle. And we can see this looks a little different, right? We have the triangle facing a different way, right? If we kind of look at this as an arrow, it was pointed this way, and now we have it pointed this way instead. But if you look carefully at this triangle, and you could use the distance formula and the slope formula to confirm this, but the angles and the sides are all going to be the same. So this is, again, even though we reflected over the origin and it looks like it's flipped in a different way, it's still congruent to the original triangle, right? So whenever you do a reflection, whether it's in the x-axis, the y-axis, or the origin, it's important to know that you end up with a congruent shape to what you started with. Even if it looks like it's oriented a little different, we can see that this actually is the same shape. All right, thanks for watching this video on reflections, and I'll see you in the next one.